to do with what happens whenever you change your dimensions. What does that do to your perimeter, and what does that do to your area? So we actually had a question back on, I believe it was 8.1 day 2, wherever they asked you to find like a composite area of a shape, and you had to convert between inches and feet, right? And some people didn't change the measurements. They just tried to multiply the area by 12, right? And that doesn't work, right? You can't just multiply the area that you found because it was in square units, right? So instead of having to go back and change your dimensions from the very beginning, today we're going to learn a trick for how you can convert easily between your area ratio and perimeter ratios. All right, so for what happened to my little box here? For number 1, we're going to draw and label a rectangle ABCD. ABCD has the dimensions of 3 units by 5 units. So on your little coordinate plane there, I'm not sure what happened to mine, but I want you to draw a box on there that's 3 units tall and 5 units long. All right, and then it says that on the same grid, you're going to draw another rectangle, WXYZ, with sides that are triple that length. Well, what is triple 3? 9. And what's triple 5? So we're going to draw another rectangle with a height of 9, or a width of 9, and a length of 15. Okay. Once we have those 2 figures drawn, they then want us to answer these questions off to the side about their perimeters and areas. So the first blank wants to know the perimeter of ABCD, and that's the first one we drew here. So what would the perimeter of that 3 by 5 be? 16. 5 plus 5 plus 3 plus 3. Good. All right, so perimeter of ABCD is 16. They also want the perimeter of the larger one that we said was 9 by 15. So that's 15 plus 15 plus 9 plus 9, which is 48. Okay. All right, then they want us to give a similarity ratio or a scale factor. Well, we said that the second rectangle was bigger by how much? 3, right. We said it was triple the length, right? So 3 in the big one is equivalent to 1 in the smaller one, right? So if we're just comparing by scale factor, that's 3 to 1. Okay, then they ask for a ratio of the perimeters for the large one to the big one. Well, our large perimeter, we said, was 48 to the smaller perimeter, which we said was 16. So 48 to 16. Can I simplify 48 to 16? 3 to 1. Okay. Now we're going to talk area. What's the area of ABCD, the smaller one? 15. Good. All right, and what's the area of WXYZ, the larger one? 135. All right, so the scale factor, or the similarity ratio, is still the same, right? We said the big one was triple the small one. So that ratio is still just 3 to 1. But then they ask for a ratio of the areas. So my areas would have been 135 to 15. Can I simplify 135 to 15? What is it? 9 to 1. Very good. All right. So then they ask us some questions about what we just found here. They ask, how did the ratio of the perimeters relate to the scale factor? So that would have been these 2 here. What do we notice about those 2? They're the same, right. So perimeter ratio and scale factor are the same. Okay, then they also ask about the scale factor and the area ratio. So that's these two. What do we notice about those? Okay, and 3 times 3, we could also write that as what? 3 squared, so it was a square of it, right? And 1 squared would still be 1, so that makes sense. It was a square, okay? So the area ratio is the square of the scale factor. All right, let's look at one more and see if we can establish a pattern between these. So on the next one, it says we're going to draw a rectangle that has dimensions of 6 by 12 for ABCD. And then draw another rectangle that has 1/3 of that length. Well, what's 1/3 of 6? 2. And what's 1/3 of 12? 4. So we'll draw a 2 by 4 for the second one. All right. So let's see here. For the large one, the 6 by 12, ABCD, what would that perimeter be? All right, and then for the smaller one, the 2 by 4, what would its perimeter be? Okay, and we said that the scale factor between these two was what? 1/3, so 1 to 3, or 1/3. Good. All right, then they also want us to do a ratio of perimeters for W, X, Y, Z to ABCD, so from small to big. So our small perimeter was 12 to our larger perimeter, 36. Can I simplify 12 to 36? 1 to 3. All right, so now let's talk areas. For the larger one, ABCD, what was the area? Very good. And for the smaller one, what's our area? Good. All right, so again, they asked for the scale factor. Did the scale factor change any? No, still 1 to 3. Okay, but for my area, small area to big area would be 8 to 72. Can I simplify 8 to 72? 1 to 9. All right, so again, how did our scale factor and perimeter ratios compare? They're the same. All right, and what about your scale factor and area ratio? How did those compare? Again, we squared it, right? Good. So the area ratio is the square of the scale factor. So it seems we have established a pattern here, something that should hold true, no matter if our area, or no matter if our scale factor increases or decreases, the perimeter ratio should stay the same, while the area ratio will be the square of your scale factor, right? Okay, so if your scale factor is A to B, remember A to B can also be written as A over B, then what should our perimeter ratio still be? A to B. So that can be written again as A over B or A to B. And what would that make our area ratio? A squared over B squared. Very good. Or remember, we can also write that as A squared to B squared. All right, so if you are given the scale factor, you can easily find out perimeter ratio or area ratio with this rule. And if you know the area of one figure and you're looking for the area of another, just set up a proportion with one of these factors, right? Cross multiply, you'll easily be able to find the missing perimeter or the missing side or the missing area. Just make sure if you're setting up one to find area, that we use the square. If we're looking for perimeter or the side length, it's just the A over B. All right?